sense. Nice. Feel free if you have any questions. I do have my chat up. So, sorry, I'm sharing a screen of me on the screen. Blah, 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 blah. That's what I want. Okay. So feel free to throw any questions in the chat, or you can always interrupt me if you need to. I do them over here on the side, just so like you can see I'm a human. And that's all I can do. So let's just get through these kind of different problems, and then we can backtrack and just do a few. I think you guys were working on it at the end of class the other day. And I don't know if you got through all of them, but I just wanted to point some of the more difficult ones out to you. So the two things, there's one of each of these on the little take-home quiz, and we might see it in the future as well. Sorry, I'll just set the camera up so I'm nice and comfy here writing. Okay. The first is how to sketch a point. And for us, we want to sketch the point 5 minus 6i. So that's a complex number, right? There's a real part and there's an imaginary part. They can't be combined together because they're from two different number systems. So we just keep it like that. So if I ever ask you to sketch that, you're probably saying like, what the heck do I do? There's an I don't know. So when we think about sketching a complex number, we think about an axis. I know we usually think about this as the x-axis. We're going to now call that the real axis. So that's where the real number goes. So in this case, the real number is 5. This, which we usually call the y, we're going to call the imaginary axis. Imaginary axis. So any of the imaginary numbers will go on there. And we'll assume, once again, there's an I with it because it's on the imaginary axis. So literally all you have to do. If the real part is 5, on the real axis, you're going to go over 5. Once again, this is just a sketch, so bear with me. The imaginary part is negative 6i, right? So, or negative 6. So on the imaginary axis, I'm going to go to negative 6. Once again, we assume the I is with it because it's on the imaginary axis. So then basically you're just going to the point 5, negative 6. So 5 on the real, negative 6 on the imaginary, and that would be your point. So if I asked you to sketch the point, that would be it. And this would be the point 5 minus 6i. So nothing too crazy. I mean, it seems like it's going to be weird because there's that I there, but it's just the idea of changing those axes where your x is your real and your y is your imaginary. So we assume that I is with that number. So let's just do another quick one just to make sure we're good. So if I said sketch the complex number and it was negative 2 plus 5i, you would say, okay, axis, we're not saying x and y now, we're saying real and imaginary. So the real part is negative 2. So on the real axis, I'm going to go to negative 2. The imaginary part is 5i, so 5. So I'm going to go to basically negative 2, 5. And that would be the point negative 2 plus 5i. And that's basically as crazy as it gets. So that's how to sketch a point when there's a real part and an imaginary part. So just as a heads up, it's basically just renaming those axes just to kind of make it fit to your desire there. So there's a few of those. When I look at like this is the problem set, it was like 102 and 103. So that was 2 of those problems that we hadn't done. So you should be able to do those now. And then the last 2 problems on the problem set was how to find the absolute value of a complex number. So let me do that quick. Once again, it's a quick little formula. So I kind of saved these for last because they were the least painful here. So absolute value. All right, sorry, bear with me. I know it's kind of annoying to watch me write on this, but what can you do? So just as a reminder, an absolute value is a distance from 0, and we're talking about it on a number line. In this case, we're talking about it on a complex plane. So if you think about this point, to find this distance from 0, you would kind of just draw a line that way. It's really kind of just thinking about the Pythagorean theorem, just going over and down. So to take the absolute value of a plus bi, you do it by using the formula, the square root of a squared plus b squared. There you go. So just as a reminder, this is the distance from 0. So once again, we kind of have a point. We're trying to find that distance from the origin, when you think about it that way. So you can go, over and down, over and across, whatever. And we're going to use this fancy little formula, which is just a fancy way of rewriting the Pythagorean theorem. So if I said, hey, what's the square root, the absolute value of 8 plus 15i, you would say, I have no clue. You would say, oh wait, I have a formula. I just plug it in. That's pretty easy. So it would be, you would do the square root of a is just 8, right? So that's just the real part. So we would do 8 squared plus, when I say b is the number in front of I, so you don't actually put the I with it. It's just whatever the coefficient to I is. So in this case, that would just be 15. So please don't write 15i there, it's just 15. I'm gonna be honest, and everything from there I just do on my calculator. So I just grab my calculator. 8 squared plus 15 squared is 289, so that's the square root of 289. And then I actually take the square root of 289, which is 17. So if you said, what's the absolute value? You would say 17. So if you kind of looked at that, where that point is, the distance away from 0, and you counted the units, that would be 17 units away. So let's just do one more quick one, guys. Remember, you're at home, so if it asks you in the take home how to do an absolute value, you just refer back to your notes. So if I said -7 minus 24i. Sorry. So once again, a, b, throw them in. You're going to do the square root. Just be careful, it's -7 squared. Make sure, especially with your calculator, you are putting those in parentheses. Plus, and that would be -24 squared. Remember, no I with it, just whatever's in front of I. I grab my calculator at this point, and I say, so -7 squared plus -24 squared comes out to 625, and the square root of 625 is 25. So that would be 25 units away from 0. So those are the last two problems. And I'm looking at the problem set here. The last two problems on here, 104 and 105, we're finding the absolute value. So you should be able to do those now. So now, we have now done, or at least been exposed to, every type of problem that we need to see. Now, we were doing some solving on Friday. And as you were trying them in your fancy little thing here, I don't know why I didn't put an answer to that. Some of them got a little bit more complicated. So there are a few that I wanted to go over just so you saw them. And then at the end, I'll see if you guys have any questions you want to go over or anything like you're still a little iffy on. And then I'll give you that time to start that take home. Okay, so I'm looking at my problem set. We were solving equations yesterday, so I think we were starting with 77. I just said, try them, see how much you can do. I put the answers up. So however far you got was okay. I was going to do the complicated one. So I'm looking at 99. So I'm on my problem set. Number 99. This is really a flawed set. We'll go with it. All right, so 99, when I just look at it, it looks a little more complicated, so I'm just going to go with it. So we have this nice little equation. By little, I mean not that little, but you know what I mean. So we have a nice equation. Our main goal, I'm assuming, because this is kind of what we're doing, was going to be solve with square roots. But right now, it's just not the setup that I need. So what I'm going to have to do first is kind of clean up the setup so then I can actually solve with square roots. I'm sorry, aggressive with my hands. and go from there. So what I'm gonna do on both sides is just simplify. So distribute out, combine like terms, all that fun stuff. So over here, I'm gonna distribute. I'll get 6x squared minus 4x minus 3x plus 2. Okay, I'm just gonna do the other side and then we can kind of simplify as we go. So over here, I'm gonna get x squared minus 2x minus 5x plus 10. Beautiful. So I can kind of combine some stuff. So what would that be? 6x squared minus 7x plus 2 and x squared minus 7x plus 10. Oh, that's delightful. Because I notice the first thing, I don't know if you guys saw this, but the x's are going to kind of cancel each other out. Oh, precious. So for square roots, I want to get the x squareds together. So let's move this x squared over here. And that's going to give me 5x squared. And then I really want to isolate that. So let's kind of do as much as we can. Let's move this constant, this 2 over here. What did I just do? Oh, no, that's right. Oh my God. In my mind, I was thinking it was 12, and that's totally 8. Okay, there we go. Okay, so we're going to divide by 5. X squared is going to equal 8/5, and we're going to take the square root. Now, there's no negative, so that's a good thing. That just means there's not going to be an I in our answer, and that can happen. Totally fine. Now, in this one, I did want to point something out to you because I don't know how much you did with radicals in the past, and I knew we were doing some dividing last week. So when I say that x squared, or excuse me, that x equals I'm going to write plus or minus the square root of 8/5. We don't leave answers like this. Yuck. We don't want fractions under radicals. Well, so we always rewrite it as the square root of the numerator over the square root of the denominator. So you can break your square roots up. You can just do the square root of each individual one. But that leaves us a radical in the denominator, which we cannot have. So we were dealing a lot with this with i's, right? So we were saying, well, you can't have an I in the denominator, so you multiply by I over I. If you can't have a square root of 5 in the denominator, you multiply by square root of 5 over square root of 5. So basically, you're multiplying by what you need to kind of cancel, which is whatever's in the bottom. That's going to give me plus or minus. Don't lose that plus minus. I get the square root of 40 over 5. Okay, we're looking better because now we don't have a radical in the denominator. This can be broken down, so just off to the side, you can do it. 40 is 4 times 10. That would be 2 root 10 over 5. And that cannot be simplified, and that, my friends, is your final answer. There is not one that complicated on the take-home PS, but I just didn't want you sitting at home being like, oh my God, I don't know how to do this, and what if I see it later? And for now, we'll just write it down. If it pops up later, we'll go over it more. It's not on your take-home specifically. There's like a few solving, but they're kind of more basic. But I never want to just throw something at you and just assume you know how to do it. So that's one I thought would be good to go over. All right, let's do another one. I'm going to do 101. There's something specific I wanted to point out in that one as well. It's kind of similar, but I'm going to flip a Rooney here. So 101. So we have a nice little equation again. Sorry, why is that a weird angle with my hands? All right, what a beauty. So we said, okay, we're gonna solve, but I can't really solve yet because there's like just too much going on. So we're gonna do some simplifying. On the left side, I'm gonna distribute. I'll get 3x squared plus 2x. On the right side, please remember what x plus 1 squared means. It means x plus 1 times x plus 1. So I'm gonna have to distribute that out. I would get x squared, and then that would just be plus 2x plus 1, and then that minus 6. Now I'm just going to start to kind of move things, just to make things a little bit nicer. So main goal, I want my x squareds on one side, so I'm going to move this x squared over here. I want everything else on the other side, right? So I'm gonna move this 2x over here, which causes those to cancel. That's delightful. I have 1 minus 6, which is -5. Okay, so that wasn't too bad, just moving stuff around. So a lot of times if things aren't in the form you need them in, you gotta put them in that form. So you gotta maybe do a little bit of distributing, simplifying, anything fun like that. Now, our main goal is to get x squared by itself, so I'm gonna divide both sides by 2, and I end up with x squared equals -5 over 2. All right, we're gonna take the square root. The first thing I notice is there's a negative. So the first thing I'm gonna do, one, when I take the square root, I'm gonna put plus or minus, but I'm gonna put an I on the outside. So I'm just gonna hold there for a second. I tend to get excited and then I go too fast. Now, this is very similar to that last one where we have the square root, but there's a fraction under it. So just as a recap of what we just did. Whenever you see that, you don't want to leave this as your final answer. So we're going to rewrite it as plus or minus. We have the I, but I'm going to split up my radical and I'm going to do the square root of 5 over the square root of 2. So instead of saying the square root of the fraction, you can say the square root of the numerator over the square root of the denominator. Now we have to rationalize. So once again, we did it with a lot of i's before, but now we can do it with radicals. Whatever's in the bottom, you multiply by that over itself. So I'm going to multiply by root 2 over root 2. Once again, the whole way I'm still writing plus or minus with the I, so don't lose anything. That would give me the square root of 10 over 2. Well, that's it, right? Square root of 10 I can't break down. Nothing's going to reduce. I's taken care of. Plus or minus we got. And that would be your x. So remember, we're getting two answers because we're talking about quadratics. Quadratics are parabolas, which means they have two x-intercepts. So that's why that plus or minus is really important. So you never want to just give one answer. As I'm looking, I don't know. I'll see if you guys have any questions or any ones you specifically want to go over. And we can always backtrack and see if there's anything. But it's more when you tell me what you'd like. Okay, give me 1 second. Okay. All right, I'm gonna unshare my screen for a minute.